Okay, so here I am in Thailand, and I'm jogging on the beach here, and I noticed something interesting. I thought I might share it with you guys. What you're looking at there, see if I can zoom in on it a little bit. That island there is Koh Lin. Koh is the word for island here in Thailand. And you can see that on the right hand side there's a little blip, but then the island itself is two big humps on the right. Okay, so just show you a little bit where I am. I'm on the beach here, this is where I jog, and you can see that island out there. That is Koh Lan. And then a little bit over here to the left, the right, I mean, zoom really in far enough. There's another little island out there, okay? That is Koh Manwachai. Alright. So what I'm going to do is I'm going to walk out towards Koh Lin, and you'll start to notice something interesting. Right now I'm about 2 meters, a little more than 2 meters, maybe 6 meters high above sea level. And as I walk down, I'm going to see something. Try to keep this camera steady a little bit. So now I'm 2 meters, right about 2 meters high. Now, you can see that that blip that was on the left has completely disappeared. Now, my contention, to me, that's this mound of earth is right in the way there. And hopefully we can show the math using Pythagorean theorem to show why that is. And let's look at the other islands out there. So that's Manwachai out there. You can see that some of it has disappeared too. And then there's Koh Lan. So Koh Lan is about 7 kilometers away. Koh Manwachai and Koh Lin are both about 21 kilometers away according to Google Earth. So what I'm going to do now is I'm going to show you the rest of the beach here. I'm going to turn around. And that's where I was standing, right where that dog is. That's about maybe 6 meters, so the camera is 6 meters higher. But now what I'm going to do is I'm going to go up into that building there, and I'm going to go up to the very top floor, and I'm going to, there's a hallway there, and that window in the middle there is in that hallway. I can get right at it. And I'm going to look at those islands again from the 27th floor. Now that building is another 100 yards away. So about 100 yards, yeah, about a football field away. So what I'll do is I'll go there now, and I'll take another video and I'll show you what those islands really look like. Okay, here I am on the 27th floor, and you can see that that island is, there's a lot more to it than you can see it down there. Let me zoom back out. That's Koh Lin, and you can see that I was standing right down there on that beach. And That's Kolin. And a little bit beyond that is that Komanwachai. You can see there's a lot more to that island too than you can see down there. So there you have it. But yeah, that is Kolin. Alright, so just to give you some geographical perspective on what part of the world I'm in. Here's Asia, and here's Thailand, and this little red square here is where I am, where the previous videos were taken. And if I zoom in on that area, this is where I am at the viewpoint here, and I'm looking out at the islands. Apologies about the mistakes I made about rights and lefts, and I think I even called Kolin a few times. So let's straighten that out right now. Basically, from right to left, as I was looking out there, the biggest island that we saw was Kolan. And I said that it was 7 kilometers out there, but according to Google Earth, when I hover over those coordinates, I get a different set of values. I think I read that in a book, and I think they were taking it from this point here to be 7 kilometers. But where I was, it was 9 kilometers to Kolan. And Google Earth, you can double check these figures down here. You can go to Google Earth and hover over the point where you're interested in, and then down in the lower right-hand corner, you'll see that Google Earth shows you the latitude and longitude coordinates. So that's what I did to get these coordinates for my viewpoint, Kolan, Komanwachai, and Kolin. And I came out with 9 kilometers, 21 kilometers, and 21 kilometers for the distance between the islands. So, and just for your information, you can go to this site right here, the National Hurricane Center, and you can input the coordinates, the latitude and longitude of both the starting point and end point. And then you can compute the distance, and it lets you do it in kilometers and even nautical miles if you want. But anyway, 21 miles, you can see that was the last calculation that I did. And so those are the details about where I was when I made that last video sequence. Now, if you want to go through some of the math that's involved and how far to the horizon, so somewhere in here, as you're viewing it from the viewpoint here, as you're looking out to the sea, somewhere out here, you're going to see the horizon, and then it's going to start to descend, and it's going to hide certain features of what you're looking at down the distance. So let's do some of that. There are websites out there, which I'll get to in a minute, that allows you to calculate this without doing the math. But I thought it would be interesting to just go through some of the math. And basically, it's all based on the Pythagorean theorem. And if you remember from high school in geometry when they were teaching you this, you know, it's a squared plus b squared equals c squared. So if you have a right triangle that's a triangle with two sides that are exactly perpendicular to each other, so there's a 90-degree angle here, you can say that this hypotenuse, c squared, the length of this, and you square that, equals the sum of the two squares here, a and b. And you can see that I've written that down here, a squared plus b squared equals c squared. Okay? So that's basically the Pythagorean theorem, and we can use that to calculate the distance to the horizon. If we sort of turn this triangle out, you can see that I put b up here on the side. So if there's a person, me, standing on the earth, and I'm going to say my eyes are about 2 meters, just to make it easier. It's less than 2 meters, but 2 meters
above the ground, and then I'm looking at the horizon. Okay? So I want to find the distance b to the horizon. Well, you can look up on the internet what scientists have found the radius of the Earth to be in both kilometers and miles, and I'm using kilometers. So looking it up, it's 6,371 kilometers. Okay, so that will be our side A, because perpendicular to that point on the horizon that we see just before everything starts to disappear, you can go straight down to the center of the Earth, and that would be the radius of the Earth. Okay, hopefully that makes sense. Then C is another side that we know. We know that the distance beneath my feet to the center of the Earth is the same as A over here. It's the radius of the Earth, right? So all we really need to do is add this 2 meters to it. But remember, we're in meters. I'm using meters as an eye height. It's a tiny distance. And kilometers is what the measured distance has been. So it's 0.002 kilometers equals 2 meters, right? Hopefully that makes sense. So C equals 6,371.002 kilometers. All right? Okay, so now let's go back down here to the Pythagoras, and we just solve for B. So using regular algebra, we have b squared equals c squared minus a squared, then solve for b. B is equal to the square root of c squared minus a squared. And then you just plug in these numbers. 6371.002 squared is this large number here. And then 6371 squared is 405,89641. And you subtract that amount from this amount, and then you take the square root, and you come out with 5.0482 kilometers. So that is B. And at a height of 2 meters, the horizon is out there at 5.0482 kilometers, right? Okay, so hopefully that makes sense. If I went through that too quickly, maybe you could just rewind and go through that again. But the other part of this is figuring out, so how much of this island out here is actually hidden? So let's do that. Okay, so what you're looking for is this X amount here that's hidden. We can use the same tools. We're going to use the Pythagorean theorem, and we're going to some of the knowns that are a little bit different here, but we know this distance here. First of all, this side D, I'm going to call it D instead of B, we know because we know that the distance that we already knew from where I was to the island is 21 kilometers. And then we already calculated B to be 5.0482 kilometers, so we just subtract that from 21, and we get D equals 15.9518 kilometers. Okay, hopefully that makes sense. Now, we also know this side, we're going to call it A again, it's the same A, it's the radius of the Earth. Alright, and that's 6371 kilometers. Now, C, the hypotenuse of this triangle, is a little bit different in this case. It is the radius of the Earth, but this X is added to it. So there's an unknown quantity here that we need to find, right? Okay, so first let's calculate the whole thing. Let's call the whole thing C sub 1, just to differentiate it from this C over here. Okay, so C sub 1 is equal to A, which is the radius of the Earth, plus this unknown quantity X, right? Okay. But C is also equal, using the Pythagorean theorem, to the A squared plus D squared. So C sub 1 squared equals A squared plus D squared. So using algebra, just figure it out that C sub 1 is equal to the square root of the sum A squared plus D squared. Now you do the same thing, you plug in all those numbers, and you come out with this number here. 6371.01997 kilometers, right? Okay, so that's C sub 1. Now let's go back to this other one. We also know that C sub 1 is the combination of this A, this radius, plus this unknown figure here. So a little bit of algebra. So we just solve for x basically, and C sub 1 minus A is equal to x. And basically you're just going to take this C sub 1, which we calculated earlier to be 6371.01997 kilometers, and we subtract A, the radius of the Earth, 6371, and we come out with basically the decimal value here, which is in kilometers. Convert that into meters, and you get 19.97 meters. So that's how much, that's x here. So that's how much is hidden from view, added to, at eye level of 2 meters above sea level, above the Earth, where I was standing at pretty much basically sea level. Okay, so lo and behold, there is a website that allows you to calculate all this stuff to make it all easier. So let's put in my numbers. So I was at eye height of 2 meters. Calculate that, and it calculates the distance to horizon was 5.048168. I think I rounded it off to 8.2. And then the hidden height is 19.97. And that's exactly what we calculated here. Okay? So that's the math that's going on behind this automated curvature calculator that we can use. You remember when I started out the video, I was about at 6 feet. And we could see a little bit more of the island. And indeed, the horizon distance was a little bit further out, 8.74, and the hidden height was only 11.79 meters. So it pretty much jives with what we witnessed out there. But then, just out of curiosity, how far would you have to go in order to see the whole island? Let's see, if I went up to 34 meters, not quite. If I went up to 35 meters, yeah, now the hidden height is 0, and the horizon, the distance to the horizon is close to 21 kilometers, and that's about how far those islands are from where I was. So then I went up to the 27th floor, and I took some footage from up there. And you can, let's see, that's about, 3 meters per floor, 3 times 27, so let's say 81 meters. So we were looking out at about 32 kilometers from that point of view, up on the 27th floor. So that showed us a lot more of the horizon, all of the island that we were concerned with, and so forth. So yeah, so hopefully that that throws some perspective on this whole flat versus spherical Earth argument. I want to give a shout out to Nathan at Lift the Veil, who did 2 things. He taught me how to use the OBS Studio with a couple of his videos that he put out there. And he also has been talking about this flat Earth, which I find really interesting. He's had a lot of people on talking about it and arguing with him. I don't believe in, I think the arguments are when they get heated, it kind of loses value. But when you can talk about things in a little bit with less emotions and so forth, maybe we can get some stuff done. But anyway, I think this video goes a little bit towards the way of showing that there is some curvature to the Earth, and it does jive with the calculations that they've put forward in some of the geographical discussions and so forth. Anyway, so let me know what you think. Put some comments down there, and you know, hopefully we'll keep going on this.